Okay, hello. So, this is the weekly update, and, I did a lot this week, so I worked on the program counter. I put all the components I had already onto the big board we're gonna put our computer on eventually. And, I'll just show you it. So, here's the program counter, so it counts up in binary, so we can actually pulse it ourselves if we want. So, do that. Oh yeah, it's actually disabled right now. So let me actually show you. Here's like the control word for the control unit to use, and we wouldn't set these ourselves, but the control unit would. So let's actually I'll just show you what type of things the program counter can do. So basically, the program counter just keeps track of which line of line of the program you're on. So we can clear it. It basically just erases what's in there. It can count forwards and backwards, and we can make it count. We can disable it by keeping this off, but we want that on. It can jump to a new line in memory. So let's say you had a line in memory where it said like, go to line 5 or something. It would just take whatever values on the bus and just put that in itself, and then it would go there. And we have the count enable. Basically, that puts whatever value that's in there onto the bus for other components to use. So it can be, well, here's the clock. So let me actually erase this. Turn it off. So there are 3 different speeds of the clock. This is the slowest speed of the clock. Here's kind of the middle speed, and here's the fastest speed. So let's just turn on the middle speed for now. Actually, no, just the slowest speed. And we can turn on the program counter, and it starts counting up in binary. And this is using my JK flip-flop, which I designed. Even though they're quite big, I designed them to have speed, because the one we had before was really slow, because we try to make it as small as possible, but small is not always a good trade-off, especially for speed, because this one can carry really fast, whereas the other one took like maybe a second to do so, even only for 3 bits. And okay, so it can go on the fastest speed, fine. It's a really fast one. So let's stop it, and we have this number. So let's say we wanted to add this number to itself, like multiply it by 2. Now let's see if that would work or not. Well, yeah, it'd be fine. So let's say we wanted to multiply the program line that we're on by 2. So basically what we do here is we load it to the A register. Well, we have to put it onto the bus first, and then we load it to the, get rid of that. That does on. Let's put it onto the A register. Let's put it onto the B register too. Okay. So there's this number multiplied by 2. Now, well, yeah, if you don't understand that, it's just because if you add a number twice, it's basically multiplying by 2. So that's how that works. So now we have to set it to the ALU output register, because we want it in that register. And then we save it to we enable it, actually. And so it goes onto the bus. And so all the components now have access to this number. And let's, I don't know, save it in registers. How about D? Just because. Let me actually hook up the levers for these, because I forgot to. So let's save it to register D. And now it's saved. And now we can disable the enable there, and then enable register D. So now register D has our number saved in it. And let's just say we wanted to now jump to that line. So we have to put it into the program counter. So first we have to clear it, and then we have to jump. So now we have jumped to that new number, to that new address, and yes, that is the number, in fact. And from there, we can just continue with our normal, duties, just counting up. And I'll show you counting backwards. So that's it, counting backwards. Okay, so it's all good. And here we have the instruction register too. I might have forgotten to show that. And here, if you're wondering, this is just the counter for the CPU cycles it'll take to execute a computer instruction. And this is just going to be used to keep track of what step of the instruction we're on, or just what micro instruction we're on, in other words. So yeah, that's basically it. Corey's this week going to work on his memory, and we're going to have 256 bytes or a 1 kilobyte probably. The 1 kilobyte might not fit on this board, but we'll see. And Sean will perfect his sound card this week. So okay, so thanks for watching. Bye.